Okay, so first off, we're going to draw the diagram, sort of thing like a graph. And so it's going to be, so here's Samantha's house. So we're going to draw a house. Here's City Park. I'm assuming it's a rectangle because it says diagonal. So something, she like runs through the diagonal. And then her school is 2 blocks east and 2 blocks north of the northeast corner of City Park. So I'm just following whatever, along with whatever. So I'm going to draw maybe bell here, because maybe that's school. Okay. So house to school. And so how are we going to go about this? And this is where I'm going to introduce a technique to you about pathways. So first of all, let's take another example wherein we have, I'm going to say 3. You're going from this corner to this corner, and you can only move up and right. These are the only 2 ways you can move. And generally, when you're trying to say the route is as short as possible, you follow the up, right movement. Most of the time, if the object is to the northeast, then you go up, right to get the shortest route possible. So it looks similar to the kind of idea that we're following here. So if you're to go upright, you would have to, in order to get to the, from A to B, you would have to go up twice, right? Because you have to cover this. And then you have to go right 3 times. So right. So you can order this in any way, and it would get you to B. For example, if you did up, right, so that would be equivalent to going up, right. If we did U, R, U, then it would be equivalent to going up, right, up. Sorry, it would be over here. Right. So this is how we would follow. So based on a set of letters, you can create a path based on that. So this equivalence we could use to find out how many ways there is to go from A to B. And the way to do it is basically equivalent to the ways to arrange letters. And the number of ways we're going to arrange the letters comes from, I guess, trying to, it's like permutations and combinations together. So the number of ways you can arrange it by, without any condition is obviously permutations. So there's 5 letters and 5 letters you have to pick from that. So it's 5 factorial, 120. But then remember that U and U are repeated and R is also repeated. So the way this works is you have to divide by the number of occurrences of something and factorial. So what I mean by that is this would be 5 factorial divided by 2 factorial times 3 factorial, because R occurs 3 times and U occurs 2 times. So, and that equals 10 if you try to solve it. So there's 10 ways to go from A to B if you write it all up. And the reason for this division is because you don't want to keep counting, because if you had something like U, R again, where you just switch the last 2, well, they look the same in terms of ordering, and they give the same path, but you just apparently switch the last 2, and that doesn't make really a difference. So that's how you do it. And in general, when you're trying to arrange letters, for example, if I had something like M-I-S-S-I, S-S-I, P-P-I, so Mississippi is the really common one. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 letters in Mississippi. But then you're going to see, okay, M occurs once, I occurs 1, 2, 3, 4 times, S occurs 4 times, and P occurs 2 times. And the point is they should all add up to 11. So you divide by 1 factorial, 4 factorial, 4 factorial, and 2 factorial. and when you divide, you get a certain answer. And so that's why this is a really important concept. So now we're going to use this idea, and we're going to try to put it into play here. So first we look at going from the school to the corner of the southwest corner of City Park. So going from here to here would mean 1 up and 2 rights. So that would be 3 factorial divided by 1 factorial times 2 factorial. And when you solve it out, that's 3. So that's 3 ways to go from here to here. So that's event A. I'm going to call that event A. And then event B is going from northeast corner of City Park to school. So that would be U, R, R. So then that would be 4 factorial divided by 2 factorial times 2 factorial, because U occurs twice and R occurs twice. So if you solve that, that would be 6. So event A occurs 3 ways, event B occurs 6 ways. So A and B occur as 3 times 6 equals 18 ways. So there's 18 different routes she can take. And remember, through City Park, there's only one path because she's going diagonal. That's it. Okay. So this is a really important concept that I introduced here. There's a lot of learning from this question. Although once you understand how pathways work and also how dividing out for multiple occurrences of the same letter and things like that work, then you will be able to easily solve questions. Okay. Example 5. The faces of 2 fair-sided dice are numbered 1, 2, 3, 5, 7, 8. When 2 dice are tossed, what is the probability that their sum will be an even number? So this is a probability question. I'll give you some time to think about it, and then we'll come back and discuss.